First of all, we want to talk about voids, and during the previous presentation you will have heard about vacuum soldering, and I'll mention it slightly from my own experience. But basically, voids is a cavity, it's a hole in a solder joint, and it's been around for many, many years. And with different types of technology, we've seen different types of voids being present. And I illustrate here intrusive reflow book that I wrote a couple of years back. You can get voids in this sort of technology as well, but it's not really a major issue. So we'll look at the issues, we'll look at how to solve it and improve process issues, but really voids in many cases are not really an issue. Or if you can see a problem happening or understand how it happens, you're a lot closer to solving a problem. So this is why I like to do process simulations. So rather than actually looking at the end result, I like to try and understand what's happening. So these two video clips just show what's actually happening during the reflow cycle of solder paste on a PCB underneath a glass slide. So we're simulating what is a component sitting on the surface. And you can see on one view, the bulk of the void is staying in place, and on the bottom view, it's not present. And this is and can be related to the material, the paste, the activity of the paste, and the gases produced during the working of the paste. Flux and cleaning and oxide formation help to create voids. So understanding why some materials react better than others is a very useful exercise. So wherever you can look at something or simulate it, break the problem down, I think that's extremely valuable, and it's not difficult to do. Now if we move and just talk a little bit about QFN, these are just some reflow clips and just showing you what's actually happening when I'm doing process simulations of QFNs. And the main reason that we get voids within QFN packages during reflow, it comes down to the design of the printed circuit board, or it comes down to the design of the stencil. So when I'm trying to understand these process issues, what I tend to do is use optical simulation or X-ray simulation to see what's actually happening in the process. And this is a very powerful tool to be able to do that. So void reduction, a few examples of vacuum now. You've already seen an excellent presentation on voids and vacuum, but I just thought I would obviously add my two penneth here. And these are examples, again, of a large transistor package. Top left-hand view is me X-raying prior to reflow, which I've already mentioned, I normally do. And then two examples, one of convection and one of in vapor phase with no vacuum. And we still got voids, but then when you reflow in vacuum with a properly defined process, you can virtually eliminate all voids. You've got to decide whether you need to, whether your customer wants you to, or from a reliability point of view, you need to eliminate the voids. And vacuum is a way of doing that.